So you ready? Come on, I need you focused. Permutations and factorial notation. So the objectives, we're going to tell you what a permutation is, and then we're going to give you some shortcuts. We're going to start out with the fundamental counting principle, and then you're going to find your calculator actually has some of these functions built in as well. Two letters, A and B, can be written in two different orders, two different permutations, AB and BA. These are the permutations of A and B. What are all the permutations of three letters, A, B, and C? How many different ways can you mix up those three letters? Well, there's one. Give me another way to mix those up. Let's be organized, not just call them out randomly. I think I could keep the A in front and do that. What other letter could I put in front? So I could have a B in front and then go alphabetical, or I could have a B in front and then mix those up. It's worth going organized so you don't miss anything. What other letter could I put in front? And then go alphabetical, or the C in front and mix them up. I think I've got, because I was organized and systematic, I think I've got them all. How many permutations of three letters are there? 6. What we want to try and figure out, Rosanna, is can we come up with that number, 6, without actually listing them all and writing them out? Okay, so how many are there? 6. I wrote down here, list all of the permutations of 4 letters. I'm not going to. There's a bunch of them. It would be A, B, C, D, A, B, D, C. Then A, C, B, D. Then A, C, D, B. You could do it in a nice systematic way, but I'm going to argue, looking at the first 2 answers, maybe we can spot a pattern. In the first example, I gave you 2 letters. How many letters? How many choices did you have? First of all, in our Scrabble bag, we had an A and a B. How many choices did you have for the first letter? 2. You pulled one out. How many were left? How many choices now? Does that give us 2 as an answer for 2 letters? I wonder if for 3 letters, if I drew 3 blanks. I have an A, B, and a C in the Scrabble bag. How many choices do I have when I reach in? 3. I pull 1 letter out. How many letters are now left? How many letters are now left? Does that work out to 6? Ah! You know what? Since that gave us the same answer as 2 letters listing them all, and this 6 gave us the same number as listing them all, I think we have an approach we can use for 4 letters. For how many letters? How many blanks? How many letters are in the Scrabble bag to pull from first of all? 4? You picked 1. How many are left? How many are left? How many are left? Without writing out all of the permutations, how many different ways are there to mix up 4 letters? How many different ways are there to mix up 4 people? 24. How many different ways are there to mix up 4 songs when you hit shuffle? 24. We're almost always, Brooke, going to go back to letters as our analogy. We're going to talk about words, but understand distinct objects. Letters are the most convenient because they are one character and all letters are different in the alphabet. But how many ways are there to mix up 4 distinct objects? That many. Oh, how many different ways are there to mix up 5 letters? Jordan, what would I write?
4 with 1.
For C, 5 letters. How many letters?
5.
And you'll notice I even abandoned the blanks. I said I've spotted the pattern. Yes? Is that okay? Hey, what is 5 times 4 times 3 times 2 times 1? Ellen? Okay. And so I got 5 people in this row. There's 120 ways to mix you 5 up. And we're already at the point where if I tried to actually list them all, I bet you I'd miss a couple. We're beyond counting on our fingers, and just with 5. Hey, What if there was 6 objects? It would be 6 times 5 times 4 times 3 times 2 times 1. What if it was 10 objects? Well, in this class, I have 25 students. How many different seating plans can I form? 25 times 24 times 23 times 22 times 21 times 3 times 2 times 1. A lot. Well beyond what I could count successfully. And again, this mixing up, this reordering, we call that a permutation. An arrangement is a permutation. Yeah, actually much more complicated. That was purely just the order, not even talking about empty desks and stuff. Absolutely. Oh, you know what? Instead of arranging letters, we can arrange objects. Jordan, what did you say for part C? How many different ways are there to rearrange 5 letters, A, B, C, D, and E? What did you say? 120. How many different ways can you arrange 5 people? 120. How many different ways can you rearrange 5 books on a shelf? 120. How many different ways can you mix up the letters of the word prove? Double check. How many letters are there in the word prove? Are they all different? Then that's really the same as A, B, C, D, and E. Now, tomorrow, Monday, we're going to talk about what if you have the same letter of... What was that?
I was joking.
What?
I just said there's 119. You can't put the O in front.
Oh, you can't put the O in front. It's a letter. 120. Jordan, what we're going to ask ourselves on Monday is, what if instead of the word prove, what if you have the word... where the same letter appears twice. Okay, that's going to be a whole different thing we're going to have to deal with. Next page. Let's go back, Kyla, to 5 letters. But instead of picking all 5 of them, what if I only want to form groups of 2? How many different... So, for example, DB is a 2-letter permutation. AE, EA, BC, CB... there's a bunch. I'm not going to list them all. I want to see if I can just calculate how many. How many letters in this permutation? No. How many letters in this permutation? 5 to pick from, but how many letters? How many blanks should I draw? How many choices do I have for the first blank? How many letters are in the Scrabble bag? Then? You know what? There's 20 different 2-letter permutations. I'm not going to list them. I'm telling you, there's 20. In other words, going back to this row here, which has 5 people, if I was forming different groups of 2 as seating arrangements, I could do that 20 different ways. You could sit next to somebody 20 different ways, assuming we count Rachel on the right and Caitlin on the left as different from Caitlin on the right and Rachel on the left, which we are here because we're saying the order makes a difference. AB is different from BA. We counted that as separate. B. How many different 3-letter permutations are there? How many letter permutations? How many blanks? How many choices for the first one, Seb? Then? In fact, I think it's going to be 20 times 3. You know how many? 60. 60. When you hit the scramble button on your... Okay, I typed this a while ago. It was back then, it was CD players. When you hit the scramble button on your MP3 player, it's doing a permutation. It's just taking the number of songs, right? And saying, how many ways can I mix them up? So let's suppose you only have 5 songs on your MP3 player and you hit shuffle. How many different permutations are there? It wants me to pick all of them, yes? It didn't say only pick 2 songs, only pick 3 songs, it said pick all of them. And what is 5 times 4 times 3 times 2 times 1? 120. How many different permutations can be formed using the letters of the word compute. How many letters long is the word compute? 7? Are all the letters different? Then you know what? This is really the same as saying you have 1, 2, let's ditch the blanks. I think it's going to be, is it not, 7 times 6 times 5 times 4 times 3 times 2 times 1, which is, don't type that in. Mr. Dueck? Yeah, Rachel. I keep noticing that we're starting with a number and we're multiplying by 1 less, then 1 less, then 1 less, then 1 less, then 1 less, and stop when we get to 1. It would be really nice, Mr. Dueck, if our calculators maybe had that built in as a function automatically. That would save us a lot of typing. Especially if, what if I say instead of 5 songs, you have 20 songs? I don't think you want to go 20 times 19 times 18 times, we can do better than that. And you do. And you do. We call this 7 exclamation point. Write that down. Except we don't say 7 exclamation point. We don't read that as 7! In math, when you see an exclamation point, we say factorial. That's 7 factorial. 6 factorial is 6 times 5 times 4 times 3 times 2 then times 1, and you would write it 6 exclamation point. 10 factorial would be, well, you know what? 1 factorial is 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. Spotted the pattern? So let's skip 4. Let's do 5. You know what? 5 factorial is 5 times 4 times 3 times 2 times 1. Let's get our calculator to do that for us. So get your calculators out. And can you go to the Run menu, to this menu here? And you're going to get to learn some new buttons. I will not help you find this on a test. You'll have to know where this is. You ready? So watch. I'm going to go really step by step. Hit the Option button, which is right next to Shift. And then suddenly that brings up a whole bunch of options on the bottom. There's something called List. We're not going to hit that. That would be F1. There's something called Matrix. We're not going to hit that. It's not just a movie. It's actually a mathematical function. Complex number, not going to do that. Calculation, not going to do that. Stats, not going to do that. And then there's this arrow sideways. That means, hey, there's more. There's another menu. Hit that. Hit F6. What we want is the probability menu, which is F what? And now you'll see F1 is X factorial. So remember I said don't calculate 7 factorial? We're going to do it on our calculator. Go 7 factorial. What is 7 factorial? 5,040. Way faster than typing 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, if you can't find that, now is your chance to raise your hand and I will come help you find it. Let me pause the video. So, can you find 5 factorial, please? What's 5 factorial? So this is 120. What's 4 factorial? Sorry? 24? Okay. What's n factorial? Here's the official definition. When you see an exclamation point next to a number, that means that number times 1 less, times 1 less, and you keep going until you get to 3 times 2 times 1. That's the definition of factorial. It says, start with the number that I gave you, subtract 1, multiply, subtract 1, multiply, subtract 1, multiply, subtract 1, stop when you get to 1. I want you to write that down because we are going to be doing algebraic factorial. In your work? No. But write that definition down. This is important. Okay? There are some restrictions. Can you try -5 factorial? Can you all try -5 factorial? Do you get an answer? Oh, sorry. Got to be careful. This is not negative 5 factorial. Bracket negative 5, close bracket, so that it knows the negative is part of the 5. Try that. Sorry, what? Does it make sense if I say you have negative 5 letters? Does it make sense if I say you have negative 5 songs on your iPad? So, restrictions. N has to be bigger than 0. Sorry, bigger than or equal to 0. Try 0 factorial. Does that work? Okay. Ready? And this time you're not going to talk when I give it away. Look up. N has to be bigger than or equal to 0. You can't use a negative. Does 0 factorial work? Yeah, what do you get? What? How does that fit this pattern here? How can you go 0, take away 1, and get 1? Wouldn't you go, if 0 was in here, wouldn't you get 0 as an answer? We'll come back to that. Come back to that. There's one more restriction. Can you try 5.7 factorial? 5.7. Get an error? Oh, can you have 5.7 letters to pick from? No. So we're stuck with whole numbers that are positive, including 0. So evaluate right now for practice. What's 9 factorial? Go ahead. What is it? 3, 6, 2, 8, 8, 0. Is that right? What's 12 factorial? 479 001 600. Again, by the way, here's what that means. If you only have 12 songs on your MP3 player and you hit shuffle, there is 479,001,600 ways to do that. That's only with 12 songs. I'm assuming most of you have more than 12 songs on your playlists. The whole shuffle thing, basically the odds of you ever hearing exactly the same shuffle more than once in your lifetime is nearly 0. Because the numbers get really big. So if you've got like 800 songs. Oh, 20 factorial. Well, we're going to run into a problem. If I go 20 factorial, I'm going to start to get an answer in scientific notation. This is saying the answer is 2.4 times 10 to the 18th. It's saying you're going to have a 2, a 4, and to the 18th. A 2, a 4, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 zeros. There's 2.4 times 10 to the 18th. Silka, that's not quite right because I ignored the 3, whatever. It's a rough. What's 100 factorial? How many different ways can you mix up 100 songs? We got a problem. We've overloaded our calculator. It can't get that big. Try 90 factorial. Can it do that? Please try this. This is for a reason. No? Try 80 factorial. Try 70 factorial. Try 60 factorial. 60 works? 70 didn't? Try 69 factorial. That's the biggest number of objects your calculator can handle. I'm sorry, we can't actually, on this calculator, calculate most of your shuffle playlists. Because most of you have more than 100 songs. Okay? You aren't going to need to memorize that, but if you ever do get a weird error, it may be you were just asking your calculator to do numbers that are so big. And I told you, these numbers get really big really fast. It was so big, it can't actually hold that number in memory. And these are good graphing calculators. I'm telling you, the numbers get really big really fast. Turn the page. Psst. Shh. Emma, my angel, can you read to me the instructions here now that we've turned the page? No, top of the page. Sorry, say that again. Go ahead. Okay. How can I do this without a calculator? This is going to be your workaround sometimes when you are bigger than 70 factorial. Sometimes, if you're clever, you can figure out what the answer simplifies to. I'll show you what I mean. So write with me, 10 factorial, what does that mean? 10 times? 9 times? We're going to write it out long. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over, what does 8 factorial actually mean? Eight times 7 times 6 times 5 times 4 times 3 times 2 times 1. Does anybody see what we can now do? I think stuff will cancel here because it's all multiplying on the top. It's all multiplying on the bottom. I think I can actually go cancel, 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 cancel. And you know what, Rosanna? In your head, do you know what 10 factorial over 8 factorial simplifies to? I guess it simplifies to 10 times 9. In your head, no calculator, which is what?
90.
Yep. Although there's an even shorter way to do this without writing out everything. There's an even shorter way to do this without writing out everything. B. What's bigger, 6 factorial or 3 factorial? Rewrite the 3 factorial on the bottom. Start to expand the bigger ones. So 6 factorial is what? 6 times? Times?
3.
Times 2 times. Oh, wait. Isn't it really, don't write this down yet. Write the 6 times 5 times 4. Isn't it really 3 times 2 times 1, what I should write? Isn't that really just that? Do I have a 3 factorial on the top?
Yeah.
Do I have a 3 factorial on the bottom? They cancel. I guess 6 factorial over 3 factorial is really 6 times 5 times 4. 5 times 4 is 20 times 6. You know what? This is 120. So C on your calculator would give you an error because those are going to fry my calculator. But which one's bigger, the top or the bottom? The top, rewrite the smaller one. 98 factorial. Start to expand the bigger one. What does 100 factorial mean? It means 100 times 99 times, what? Times 98, isn't it 98, 97, it's times 98 factorial, because that's really what you can abbreviate it with. Erica, what's going to happen to the 98 factorials? Are you saying that this simplifies to 100 times 99, which I would argue I can probably do in my head? I think it's going to be a 99 with 2 zeros. That's the workaround that we can sometimes do if we want to actually evaluate something bigger than our calculator can handle. Got to be clever, but I'm sorry, the technology it's limited. The numbers get really big really fast and they overload the memory. Example 3. Example 3. How many 3-letter permutations can be formed using the letters of the word compute? How many letters are there grand total in the Scrabble bag? 7. How many am I picking? So I could do this by going, you got 7, you got 6, you got 5. But I want to show you an even quicker way to do this. I'm going to argue that this is the same as 7 factorial divided by 4 factorial. Say what? Because would I not, Emma, could I not, first of all, which one's bigger? Expand it, it would be 7 times 6 times 5 times 4 factorial. The 4 factorials would cancel, and I have that left behind. That is built into our calculator. That is built into our calculator. From 7 objects, permutate 3 of them. It will do that for you. Give you. How many letters? Count carefully. How many letters?
7.
You see where that 7 came from? How many letters am I picking?
3.
How could I get a 4 from a 7 and a 3? I haven't written that yet, but I'm glad you asked. We're gonna notice you have to do a little subtraction, okay? But this is built into your calculator. We would write this as from 7 letters, permutate, capital P, 3 at a time. That's how we write it. Hey, do you have an NPR button on your calculator?
Yeah.
From 7, permutate 3 of them. That is going to go 7 factorial divided by 4 factorial. That is going to go 7 times 6 times 5, which 210. Sorry? It's right next to the factorial. It's all in the same area, right? This is why I made all of you get a graphing calculator. This is crucial. It's right next to the factorial. This is, okay? Here's the notation. If you see 7p3, what that really means, this is going back to Rosanna's question, is this. 7 factorial divided by 7 take away 3 in brackets factorial. If you want to know how many ways to mix up 7 letters if you pick them 3 at a time, it's that. Can you see, Rosanna, now where the 4 came from?
Yeah.
What if I wanted to pick 2 letters at a time? It would be 7 factorial over 7 take away 2, 5 factorial, or 7p2. What if I wanted to pick 1 letter at a time? We'll practice this. But here is our formal definition. Okay? An ordered arrangement of distinct objects is called a permutation. In fact, the trigger word is usually going to be the word arranged or arrangement or mixed up or shuffled. The number of permutations of n distinct objects, if you're picking all of them, it's just that. If you're picking all 8 letters, it was 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. If you're picking all 5 letters, it was 5 times 4 times 3 times 2 times 1. If you're not picking all of them, if you're only picking a certain number at a time, we write that like this. N, P, R. You have n objects and you're picking R at a time. You got 8 letters, you're picking 2 at a time. You got 10 letters, you're picking 5 at a time. You got 6 songs, you're picking 3 at a time. And underneath we're going to say NPR is defined as n factorial all over n take away r factorial. Your calc has this. Your calculator has this. So let's pick some nice round numbers. Let's suppose on my iPod I got 100 songs. And I want to create a 5-song playlist shuffle. How many different ways are there to mix up 100 songs if I pick 5 at a time? Get your calculator out. 100, permutate, 5. That many ways. And this is nice, Justin, because the permutation menu, the P thing, that can handle factorials bigger than 70. I fibbed to you a little bit. I said, we're going to be stuck with less than 70. Actually, no. It can handle more than that in this submenu because it's actually canceling stuff out before it does the math, and so we're not overloading the memory. I have 25 students in this class. Let's suppose I want to find out how many different combinations I can put at that front row corner table right there because it's driving me crazy. 25, permutate, 2 kids. I got 600 different possibilities I could put in that desk. That's assuming I count Emma then Jordan as different from Jordan then Emma. What if you don't want to count them as different? Later, we'll get to that. Okay? A little more complicated than that, but it's going to involve some division, yeah. With me so far? Have our lovely math comic. English friend says, gives me $10. A math friend says, give me 10 factorial dollars. What's the difference? Right? Or there's another old joke. It says this. How old are you?
17.
So, ready? Here's the joke. Listen close. Foster, how old are you?
17.
I want you to answer me excitedly with the same number. Foster, how old are you?
17.
No, you're not. Huh? Huh? Because 17 factorial. 17. If you type that, I would argue, no, that can't be right. That would mean that you were that old. You're not. Dumb math jokes. Okay? So, on your calculator, evaluate the following. Can you right now find 8p, and we're just going to say 8p7, or you can say 8 permutate 7. So, evaluate that. Oh, and evaluate 21 permutate 18. Try that on your own, please. $40,340. Wow. 8.5 times 10 to the 18th power. That's a big number. Okay. She's handing in homework as though she was working on it during the lesson. No, she would never have been working on it during the lesson. Okay. And we're going to finish off with C. We're not going to get to solving. That's going to be when we come back on Monday. So C. How many different ways can we arrange the letters of the word Kelowna? Double check how many letters in the word Kelowna? 7? Are they 7 or 6? 7. Are they all different? Okay. If they're not, our method no longer works. If we have the same letter showing up more than once, we'll get to that another day. How many ways can I rearrange letters of the word Kelowna if I choose all 7? What's the short way to write that? Brooke. By the way, Brooke, that also happens to be from 7 permutate all 7. That'll also get you the same answer as it turns out. Why? Because mathematically, that would be 7 factorial divided by 7 take away 7 factorial. The bottom part would.
So it's kind of pointless, but it's kind of...
What do you get? I want an answer. What do you get? 5040? Okay. What if we choose 5 letters at a time? You could either go 7 times 6 times 5 times 4 times 3. Shh. You could either go 7 times 6. You could draw the blanks, 5 blanks. Or we have a shortcut now. From 7 letters, permutate 5 of them. Stop whistling, whoever that is. Thank you. And you're in grade 12. Really? I got to tell someone to stop whistling during the lesson? Come on.
Well, Mr. Kamosi still
Pardon me?
does. Mr. Kamosi still does.
Well, I don't, and you can't. Thank you. Jordan, what am I going to write here for 3 letters at a time?
7, 3, 3.
And again, what that really means is 7 factorial over 4 factorial. What this really means is 7 factorial over 2 factorial, because it's 7 take away 5, that's what goes on the bottom. It's 7 take away 3, that's what goes on the bottom. $210. 1 letter at a time. That's going to be 7p1, which is really 7 factorial over 6 factorial. I think that's going to be just 7, isn't it? Oh yeah, because I would draw 1 blank. 7. That'd be it. We're going to pick this up, but there's 15 minutes left. I'm going to give you some questions to try, and then we're going to add to those questions when we finish this on Monday. Okay? So for now, from page 243, you can do number 1 is fair game. 3 is good. 4 is good. 3 to 5. Can't do 6 yet. 7 is good. 8 is good. I skipped 9 apparently. 10 is good. Can't do 11 yet. 12 is good. 13 is tricky. I'll put a little star next to it. 14 is tricky. I'll put a little star next to it. Meh. Did I want to do 15 yet? Okay. Now, is this homework? I'm going to continue this on Monday. What I do want for the remaining 15 minutes, though, is use this time to get a good chunk of this done. Don't go all loopy. Oh, I got a long week. I don't want you to have to work a lot of work on the long weekend. So use this 15 minutes. You can whittle away at some of these. I'm going to add to this as well. Permutations. Kind of cool.